Hello, anyone. Welcome to the spring version of A Roadmap of the Stars. My name's James. I'm the fly science guy, and I have also with me here my fiance slash co-producer slash writer, Becca. Say hi.
Hi, I'm Becca.
So, a few things before we get started. New year, new show. I am gonna kind of change up how I do things. I used to start every show by talking about the northern sky in depth because honestly, to me, it is the most important part of the nighttime sky because it doesn't change that much throughout the year. So it's an excellent part of the sky to practice your astronomy on. But also, because I focus on it so much, it eats up a lot of the show, and then the show ends up running for an hour, 2 hours. So to combat that, I'm going to only do a very brief part of the Northern Sky. Instead, what I'm going to do is I'm going to make a video about the Northern Sky, kind of like an Astronomy 101, and that way you can watch that video anytime you like. You can use it to help you practice your astronomy, because all the constellations in our northern sky, from our perspective, around Pittsburgh area, 40 degrees latitude on the Earth, United States area, the northern sky doesn't really change that much throughout the year. And it's also pretty much where the breadth of my intro to how you look for constellations and the difference between constellations and other figures in the sky. So, if this is also everything we do, we rely on your guys' feedback. So, if after this show you think, well, I don't actually mind you talking about the northern sky first before the show, I don't mind when shows run long, let us know on our website, flyscienceguysstarshows.com. The contact page, you can send anonymous feedback, and we highly encourage it. And you can just let us know what we did right, what we did wrong, and that will help us make better content in the future. Also, Roadmap of the Stars is now going to be a quarterly show, so every season change is when we will do another Roadmap of the Stars. So today is the Equinox. So this is the spring Roadmap of the Stars, where I'm going to talk about the next 3 months. Well, the rest of this month and the next 2 months of constellations that you'll see in those individual months, leading up to the summer solstice. And then we'll do the next show on the summer solstice, and I'll talk about every constellation up to the autumnal equinox, the beginning of fall, and so on and so forth. We're going to sprinkle in some of our other shows as well. We have a bunch of awesome ideas from all the people who answered the survey and shared the survey with friends. We got responses from people who watch the show regularly, watch the show occasionally, never watched the show at all. So we got a lot of good information, and we have a lot of awesome shows coming at you guys, with the next show being on May 8th. And you can see our schedule of shows on our website as well. But May 8th is going to be a show all about eclipses, lunar eclipses, solar eclipses, why they happen, why they don't happen all the time. So keep an eye on our website, and we'll of course update you guys on Facebook. But yeah, I think that's fine for now. I'm going to go ahead and get started with the show. Now, what I want to start out, I am going to talk a little bit about the northern sky, and the reason is because I want to point out the Big Dipper. I want to point out why it's useful, because we use it later on in the show. So, of course, the first figure I'm going to show you is the Big Dipper. I kind of gave it away there. 4 stars in the pot, and 3 stars make the handle, the Big Dipper. Now, I'm using a program called Stellarium, and I am simulating the nighttime sky as would appear tonight at 9 o'clock. So you'll be able to, after this show, eat dinner, go to a dark place, try to find some of these things that I show you. So this, and I'll tell you guys when we change dates, because I'm going to take you through the next 2 months as well. So this is the northern sky at about 9 o'clock tonight. And you'll find the Big Dipper pretty high up in the sky. 4 stars in the pot, 3 stars in the handle. Now, something that not everyone knows about the Big Dipper is that it is not actually a constellation at all. It's what's called an asterism. And an asterism is just a fancy word for a star picture. Aster meaning star, ism meaning shape or figure, asterism, star picture. You can make up whatever asterisms you want in the sky, your own personal collection of asterisms. Like over here, we might have the Northern Dorito chip. Oh, they're not. Actually, maybe I should go off-brand. They're not paying me to say that. Northern Indescript corn chip with cheddar powder on it. Over here, we might have a salad bowl. You can make up any figure you want. It's all yours. But they're not official constellations. Constellations are different from asterisms like the Big Dipper in that all astronomers agree on the constellations in the nighttime sky, and the importance of that is it makes a map of our nighttime sky. Now, though the Big Dipper isn't a constellation, it is part of a bigger constellation, Ursa Major, the Big Bear. It does have a very long tail for a bear. It's certainly not a grizzly bear. You can think of it as maybe a giant red panda, if you want. Are pandas considered bears?
I don't know, but shout out to Brandon Nielsen because red pandas are his favorite animal.
Well, Brandon can imagine a red panda, Ursa Major, the great bear, the great red panda.
I'm gonna actually put that question to Brandon. Brandon, you have to answer. Are red pandas considered bears?
As he's answering that, the Big Dipper is really useful to astronomers, even though it's not a constellation itself, because we can use it to point to other constellations and other stars. We're going to do that by something called star hopping. Star hopping is where you take brighter, more noticeable stars, and you use them to find dimmer, less noticeable stars. And the Big Dipper is really good at doing that in a lot of different ways. It points to a ton of awesome stars and constellations, but there's one particular star that I want to use the Big Dipper to find for you guys right now. And the way we're going to do that is we're going to use the front 2 stars in the pot of the Big Dipper. And we're going to call them our pointer stars. And we call them that because if we imagine connecting the 2 stars together and going straight out, they point to that very special star. This star, right here. This star's name is Polaris, and Polaris is our North Star. Now, there's a bit of a misconception behind the North Star in that a lot of people are led to believe that it is the brightest star in the nighttime sky. Now, here in Stellarium, it does look pretty bright, but that's really just because Stellarium likes to emphasize more important stars. But if you go outside tonight, if it's clear, I'm told that it will be clear, and you use the trick of finding the Big Dipper, using the pointer stars to find Polaris, you may find that it's actually very, very dim compared to a lot of the other stars in the nighttime sky. No, the Big Dipper is famous for a completely different reason, and it's given in the name. The North Star is famous because it is a star that is always directly in the north. Now, some of you might be a little skeptical because you may have noticed quite a few stars that might be considered directly in the north right now. But Polaris is special. Polaris gets its official name Polaris because it's our pole star. It's the star right above the Earth's North Pole. Now, the important thing of that is that as the Earth spins, since Polaris is right above the Earth's North Pole, as the Earth spins throughout the night, all the stars appear to sail across the nighttime sky, rising and setting. But the closer we get to Polaris, the stars stop setting. They just begin to make smaller and smaller circles until we get to Polaris, our North Star, where it doesn't appear to be moving much at all, as I hold my mouse cursor still right next to it. So, the North Star is famous because it is a star that is always directly in the north. If you find the North Star tonight, you'll have found it for the rest of the night, the rest of the year, the rest of your life, because the North Star will not move very far from this spot at all. Now, the North Star is part of another famous figure, another collection of 7 stars, 3 stars in the handle and 4 stars in the pot. Since we have a Big Dipper, it would only make sense that we also have a Little Dipper. Now, the Little Dipper is also, it's an asterism. It belongs to the constellation of Ursa Minor, the Little Bear. Now, your eyes aren't deceiving you. When I showed that it's part of Ursa Minor, no new figures shown. It's drawn out the same way. So, I mean, sometimes astronomy doesn't impress, but it's still good to know that the Little Dipper and the Big Dipper are not constellations. They're not constellations, and the constellations actually are Ursa Major and Ursa Minor. Take that to a bar trivia, maybe you'll get lucky. So that's the northern sky that I'm going to at least just cover in this stream. Like I said, pretty soon I'll be putting up a whole video about the northern sky and pretty much an astronomy 101 for visual astronomy anyway. So what I want to focus on instead for the rest of this show are our southern constellations. These are also known as seasonal constellations because these constellations change throughout the seasons. You're able to only see these certain constellations at certain points of the year. Unlike the northern sky, where it's the same pretty much all year round. Now, I want to start off by saying goodbye to our wintertime constellation. I don't want to spend too much time on them because today is the first day of spring. We don't want to think about winter anymore, even if you like winter. I mean, it's cold. We want the warmer weather. We want longer days and being able to go outside without having to put on 5 layers of clothes. I don't know. It might just be me. I don't like the cold. I like winter because winter is an excellent time to do astronomy. Longer nights, less humidity in the air. It makes it an excellent time for viewing the stars. During the summertime, you have shorter nights, so you don't get that much time to look at the stars during the summer, but it's admittedly more comfortable, and honestly, I would take warmer summer nights for a shorter frame of looking at stars than having to freeze out in the cold all night looking at stars. But that's just me. So I want to say goodbye to our wintertime constellation. And what more notable constellation to point out and say goodbye to than one that I'm sure you noticed me kind of hovering around. And it's this guy right here. Famous for the 3 stars that form his belt, this is the famous wintertime constellation of Orion, the Hunter. Now, as we move further into the month and further into spring, we will see Orion setting... So right now, I'm moving forward days. So this is the 20th, moving to the 21st at 9 o'clock, the 22nd at 9 o'clock, 23rd at 9 o'clock. And we see as we get further into spring, Orion sets earlier and earlier every day. And as we move further past spring and we move into getting closer to the summer months, the sun sets later and later. So around this time, it doesn't get dark till 10. So we see Orion is really far in the western horizon now. But why is that? Why do these constellations only occur at certain times of the year? Why do they set, and why do our days get longer during the summer? Well, to answer that question, we have to understand how our Earth and the Sun interact with each other. Throughout the year, our Earth orbits the Sun. And as the Earth orbits the Sun, our perspective of what we see in space changes. So down here we have what's called the ecliptic. And the ecliptic consists of 12 what are called zodiacal constellations. So as the Earth orbits around the Sun appears to trek across our nighttime sky. So I'm going to, as the Earth goes round, this is about where we are right now. Now, the equinox today is, well, today, and today's not the 21st, so why do I have March 21st here as the vernal equinox? Well, that's because a lot of the times on calendars, you'll usually see the equinox lie on September 21st or March 21st, and the solstices sitting on June 21st, December 21st. Those are called the ecclesiastical equinoxes and solstices, and that means that these are the equinoxes and solstices, as recognized by the Christian Church. It makes some of their holidays that rely on where the sun is in the sky, it makes it easier for planning. So throughout your lifetime, the date that the equinox lies on and the solstices lie on drift back and forth between the 20th and the 23rd, but that's not convenient for planning out years in ahead for holidays. So the Christian Church has it marked down as the 21st on the respective months. So anyway, March 20th. As the Earth goes around, the sun around March 20th will be right over here, as you'll see in a little bit. And here is how much of the sky the sun actually blocks out. It doesn't block out that much, so constellations don't stay hidden for very long, but who wants to get up at 5 in the morning to look at constellations? When you're heading into work, maybe, but it's not safe to look up at the sky when you're driving. Keep your eyes on the road. But so when we talk about constellations and the seasons they belong to, we just mean the constellations that rise out of the east as the sun sets in the west. And right around here is where the sun is right now, and here's Orion. So we see as we trek further around the summer solstice, the sun and Orion are about in the same place in the sky. So you won't be able to see Orion because he'll be up during the day and he'll set with the sun in the evening. You have to wait until the morning time of around August, where Orion rises in the morning just before the sun does. Now, this is why constellations only appear at certain times of the year, or at least the southern constellations do. But does this explain the changing seasons? It does, but in a different way. So seasons change not because of how close the Earth is to the sun. I know when I was in elementary school, it blew my mind to find out that the summertime in the northern hemisphere, where we live, is when the Earth is furthest away from the sun, and the wintertime in the northern hemisphere is when the Earth is closest to the sun. Now, that's a key indicator that our seasons are not dependent on how close the Earth is to the sun. Our seasons are dependent on how much sun our northern hemisphere is getting. So during June, the Earth is tilted towards the sun. So more of the sun's rays end up hitting the northern hemisphere, and less of the sun's rays end up hitting the southern hemisphere. So for us, whenever it is summertime in America, for Australia, it's wintertime, because Australia is in the southern hemisphere. during the winter solstice, more of the sun's rays are hitting the southern hemisphere, whereas less of the sun's rays are hitting the northern hemisphere, meaning that we get less sunlight turning into heat in the northern hemisphere, so it is wintertime for us in the northern hemisphere in America, and it is summertime for people who live in Australia in the southern hemisphere. But the tables balance out during the equinoxes, because as the sun goes as the earth goes around the sun's rays hit in equal amounts in the northern and southern hemisphere. So not only do we get the same amount of heat as each other, so the temperatures are kind of similar, but we also get the same amount of light, the same amount of day, and the same amount of night. In fact, that's where the name equinox comes from. Equa meaning equal, nox meaning night, equinox equal night. Now that can be kind of hard to visualize, so I went ahead and made another graphic to help kind of visualize how this looks throughout the seasons, because everything kind of seems stationary out in space, because to us it feels like it's going really slowly because everything is really far apart. But if you were to capture the sun at its highest point every day throughout the year, it would look like this. So going back to here, as the Earth goes into the equinox, the sun is setting lower and lower, or it's getting lower and lower in our skies as we move from fall into winter. And then the solstice, sun still, is when the sun appears to slow down and stop during the winter solstice. The sun appears to go back up as we get closer to the vernal equinox, or spring, the first day of spring, as the sun gets higher in our sky. And during the summer solstice, it is at its highest point in the sky, where it appears to stand still again and then retreat back down. Now, our ancestors knew this for a really long time. They noticed that the sun set lower and lower in the sky in the winter and got higher and higher in the sky during the summer. And our ancestors had a lot of different stories, had a lot of different beliefs to explain and to remember that the sun gets lower in the winter and higher in the summer through various stories. You know, the Egyptians believed that the sun god Ra was getting sick, and so he was setting lower and lower in the sky to recover. And the summer solstice was a time, or the vernal equinox, springtime, was a time of celebration because Ra was coming back up. He was getting healthier. The Mesopotamian ancestors, they believed that they had temples built for the sun. I forget the Egyptian god name, but it's for the temple Chichen Itza. I'm not going to spend any more time on that. I don't remember. I'll post something in the supplementary information about that.
I just want to provide a clarification. Not sure if you mentioned it, but just when you're talking about the sun setting, this image is showing the sun at the highest point it is every day throughout the year, right?
Right. So this is what's called solar noon, and it is different from regular noon. It's the point that the sun reaches its highest point in the sky at each day. So this is the highest point in the sky during June 21st, and as we get further into July and September, this is the highest point the sun reaches. So it's not that the sun is setting like it does normally, it's that this is the highest point at that time of year, with the winter solstice being the lowest that the sun gets, and the summer solstice being the highest that the sun gets. Whoops. So, does that make sense?
Yeah, it just puts it into perspective. Like, I feel so much better in the summertime. There's so much more light when you look at how low the sun is.
It is, and that's
in the sky. Like, at its highest point in the winter, it's so low. the rays would be so dilute.
Yeah, so that's another reason as well why we have shorter nights, because as we're watching the sunset, it's not like it's not that the sun is going to be up and the arc gets more shallow to make sure that the sun is up for the same amount of time. We know that during the winter time, we have less daytime. And that's because as the sun sets, the whole arc that the sun makes gets lower. So like this is the arc during winter time, this is the arc during the equinox, this is the arc during the summertime, and so during the summertime, the sun is up in the sky much, much longer because more of its arc is visible from the northern hemisphere. Whereas during wintertime, the sun is up for less time, which leads itself into why seasonal depression is a thing, because then our bodies get less vitamin D that our bodies make from the sun's light, and then we just get sad. We get more sad than before. So I don't want to talk anymore about the winter sky, because the winter sky is leaving. It had its chance. We talked about it in December. We're moving on with our lives. So I'm going to move us right now. We're looking at the sky, or we've been looking at the sky as it'll appear tonight around 9 o'clock. May 20th? March 20th. I know my months. So I'm going to move us to April 20th, and I'm going to make it 10 o'clock, because during April, as we move further into spring again, the sun gets higher in our sky, so it sets later. So it's a good time to go out around 10 o'clock in April. April 20th is what we're seeing now at 10 o'clock. Now, the springtime constellations that I want to introduce at this time of year, we're going to use the Big Dipper to help us find in Ursa Major again. So earlier, in the northern sky, I taught you guys to use our pointer stars to find Polaris. Well, to find some of these springtime constellations that you'll be able to see in April, we're going to use the handle of the Big Dipper. So there's a little mnemonic device that, if you ever took an intro to astronomy class, it's one of the little rhyming couplets that's drilled into your head throughout the entire class. And that is, first of all, a mnemonic device is a memory device. So it's anything that helps you remember something better. So making a story out of it. Our ancestors did that all the time with stars and constellations. That's why we have the stories that we have. You can do it for yourself in everyday circumstances. Like, there are people who make a living out of being super rememberers, and one of the tricks they use is making a story out of whatever they have to remember, using the details from that thing. So, but mnemonic devices also come in rhyming couplet. And the mnemonic device I'm going to teach you to find these stars and constellations is we're going to start at the handle of the Big Dipper, and it goes, we're going to arc to Arcturus, and then spike down to Spica. So going from the handle of the Big Dipper, arcing to Arcturus. Arcturus is the brightest star in the constellation of Boötes, the herdsman. Spiking down to Spica, Spica is the brightest star in the constellation of Virgo, the maiden. Now, I know what you're kind of thinking. Some of you might be thinking it. I know I think it a lot of times. These constellations don't exactly look like what I'm calling them. Boötes doesn't exactly look like a herdsman. He looks like an ice cream cone, or a kite, or a tie, like big old ties that, like, 60s dads would wear. Virgo, I don't know what Virgo looks like. It looks like a square squid with tentacles. See different things. But it's not that important that these constellations should look like what we call them. What's important is the meaning or the purpose that the people who made them up gave them, these mostly being the ancient Greeks and Romans. It was very important that they remembered these constellations relative to seasons because they use the stars not only as a way to tell stories, but on top of that, they use them as a clock and calendar. Depending on the constellations that they saw in the early evening sky, that is, the stars that rise just out of the east as the sun sets in the west, based on the first stars they see in the sky after the sun sets, they could tell when springtime was coming, and they needed to get their fields ready to plant their crops so they could feed themselves, their families, their village. They could also tell when winter was coming and needed to bunker down their houses so they could stay warm during the cold, cold winters. And they remembered these constellations not necessarily by what they looked like, but by the stories they told of them, going back to the mnemonic devices. And again, we have the stories still today, not because we use the constellations in those same ways, but because they were passed down from generation to generation. Our ancestors who had kids, those kids had to grow up and learn how to tell when spring and winter time was coming. But today it's not as important, but we know kind of how they used them from long ago based on tablets that they may have etched stories into or artwork that they had. For instance, Virgo was a sign of fertility and harvest. And so she's often depicted as holding crops and a sprig of wheat in her hand, which is represented by the bright star Spica. So when our ancestors saw Virgo, or more importantly Spica, rising out of the east, they knew it was time to get their fields ready to plant their crops because the farming season was coming in. And there are other stories as well. There's another one that I'll tell you guys as we get closer to the end of the show. And also, later down the line, we're going to have a whole show based on these mythologies. So you have to stick around, keep an eye on the calendars, find out whenever we announce the release date of that show. But so Virgo is our springtime constellation who signifies the beginning of the farming season. We have another constellation that I want to point out as well, just because I think he's an interesting constellation and I like it. If we use the back two stars in the pod of the Big Dipper, so not the front two stars nor the handle, but the back two stars in the pod of the Big Dipper, we can go, it points straight down to a brighter star here. And this star is named Regulus, and Regulus roughly translates into King Star, which is fitting because it is the brightest star in Leo the Lion. Now, Virgo and Leo, if they sound familiar, it probably shouldn't be too surprising because they are 2 of the 12 of the zodiacal constellations that I was talking about earlier. So when you know where your zodiacal constellations are, you get an idea of the path of the sun, because the ecliptic lies over our zodiacal constellations. So this is the ecliptic, this is the path of our sun. Over here setting is Taurus the bull, Gemini the twins, and Cancer the crab. So Cancer is really hard to see. You're going to be able to see Gemini pretty much all throughout spring. You'll be able to see the 2 brighter stars that of the heads of the twins, Pollux and Castor. And you can find them by, if you're able to see Orion, using the bottom right foot star of Orion and the upper left shoulder star of Orion, connecting these 2 stars together and going straight up. And you'll find the twins, Gemini. Use his 3 belt stars, connect them all 3 together. They point over here to Aldebaran, which is the eye of the bull, of Taurus the bull. So those are some of the zodiacal constellations that you're also able to see, but you don't have to worry about these other ones because they are setting. Really just focusing on Virgo, finding Virgo by arcing to Arcturus, spiking to Spica, and using the back 2 stars to find Regulus. Another easy way to find Leo is look for a backwards question mark in the sky. It's very noticeable, and once you start finding these little asterisms like the backwards question mark, the ice cream cone, it's a lot easier to then find your way around the rest of the sky. And if you keep following us throughout the year, I'll be showing you all the seasons' memorable asterisms and how you can find those constellations that they belong to. Now, we have some events for the... well, one event for the month of April. And I haven't been keeping up much on it. I know that in the past I have seen people talk about this phenomena, but coming up, we have what people have affectionately started calling the supermoon. And a supermoon is just an occurrence where a full moon or close to it occurs near perigee. Now, the reason I want to talk about it is because when I did see stuff on the supermoon, anytime a supermoon comes around, there would be people saying how rare it is, and people who believe in astrology would talk about how people need to make life decisions based on it or other movements of bodies in the sky. And before I move further, I do also want to a little vocabulary that astrology is not the same thing as astronomy. Yes, I will explain perigee in just a second. But astrology is where people believe that the movement of bodies like the sun, the moon, planets that we can see in the sky have an effect on you as a person or have an effect on the events in your life. And that is not true for a lot of different reasons. Mainly because the effect of these bodies out in space do not have that much of an influence on you. For instance, the moon has less of an effect on you than the pillow that you sleep on at night. So there's more credence behind your pillow saying something about you as a person than the moon. But off of that soapbox, astronomy is what we're doing now. Just talking about the stars, talking about the universe, talking about physical measurable properties. And that's not, I understand the fun in horoscopes. I do. I never want to be like a buzzkill for those kind of things, and I try not to be. The reason I bring those things up is just because, like, there are people who would take advantage of people based on a belief in astrology, and it's fun to, like, read horoscopes and stuff, but I just don't want people to be swindled by other people who know that they can take advantage of people like that.
Yeah, just gonna chime in, like, just mainly clarifying that astrology is not a science. It's more akin to, like, a religion. And so if you want to believe in that as a religion, just know that it's not a science and there's no scientific backing to it. And so, just to re-emphasize what James said, he just wants to make sure, don't, if someone tells you to sell all of your belongings because we have this crazy astrological or, like, astronomical event, the supermoon, because it's so super rare, now you have the knowledge to be able to say, it's actually not that rare. And there's no scientific backing to support the fact that I should sell my house because of this or anything crazy like that. But it is a cool astronomical thing to look out for, even though it's not incredibly rare. So, James, you want to go off of that?
I do, yeah. So that leads us into what a supermoon is. So I used the word perigee just a second ago. So, a lot of time when we learn astronomy in elementary school or middle school, it's really useful to talk about, like the orbits of planets or satellites in the sky being like perfect circles, right? They're not. So they're more of what's called an ellipse, which is more like an oval, really. So you guys get to see my awesome artwork. So this is a bit exaggerated. It's not this extreme out in space, but just to make the understanding clearer, orbits are a little more elongated, and they have points where a body is closer to what it's orbiting and further away to what it's orbiting. And if we think of this as the Earth and this is the Moon, the point at which the Moon is the closest to the Earth in its orbit, that is perigee. The point where the Moon is furthest away from the Earth, that is apogee. So a supermoon is when the moon is a full moon and at perigee. Now, a full moon occurs when the sun, the Earth, not to scale, and the moon are all in a line with each other. And the sun's light comes in and it lights up the front face of the moon, or the face of the moon that's always pointed toward us. And this is a full moon. Now, whenever the moon is full and at perigee, it looks slightly bigger in the sky. And I say slightly bigger, it's just marginally. So if, for instance, this is how the moon looked between apogee and perigee, apogee, the moon would just be ever so slightly bigger, and apogee, the moon would just be ever so slightly smaller. And so the full moon is when we get a really good look at the moon when it's in perigee. Now, this isn't rare. The moon orbits the Earth about once per month. So the moon orbits the Earth about 12 times in a year, between 11 to 13 times in a year, because it's not perfect. It's not exactly 12 months, or it's not exactly 1 month that it takes for the moon to orbit the Earth. It's a little bit off. But as the Earth orbits the sun, the moon is obviously in for the ride as well. So this is the moon and the Earth. This is its orbit around it. And as the Earth orbits the sun, the moon's orbit is pretty similar. So at this point of the year, perigee would be during a full moon. But if we wait 6 months later, where the Earth is on the other side of the sun, now the full moon occurs during apogee. But then, next year, the Earth is back over here again, and the full moon would be again close to perigee. But it even happens more times than that. The Earth doesn't move quickly around the sun, at least in terms of human lifespans. It moves slow enough that you get close to a supermoon about like, months back to back. So a supermoon can occur anywhere from 2 to 4 times in 1 year. And that's every year. That you'll have the supermoon somewhere between 2 and 4 times. So it's not rare. It's not rare for a supermoon to occur. If you wanted to get really nitpicky, it is rare for the moon to exactly fall on a full moon during perigee. But for instance, this year, we have the moon at 99% full, so that is almost exactly a full moon at perigee in April, on April 27th. And then the next month, May 25th, it's again 99% almost full moon at perigee. So that's 2 supermoons months back to back. And it'll be similar next year as well. Now, there are some complications with how the moon orbits. So when these supermoon, air quotes, when these supermoons occur, drifts throughout the year, or throughout years going by. So throughout your life, the supermoon will drift later and later into the year. But that's a discussion for our eclipse show in May. But for now, I just want to say, like, there is a supermoon, and it's great. And I'm probably going to take my telescope out to look at the moon, because it is going to be in perigee. It is going to be slightly bigger, and it is going to be a full moon. So it is fun to look at. The only reason that I bring this up again is not to be like, oh, this super cool event is nothing special. Everything's special in astronomy. It's all fun. I just don't want people being taken advantage of by Uncle Joe on Facebook saying that he's going to put $1 million into the lottery because it's a supermoon. It happens every year, and it's a great thing to see every single year, but don't make any big life decisions off of it.
Can I summarize just what you said to make sure that I'm understanding it?
Sure.
So, perigee is when the Earth is closest to the sun, essentially. And
perigee is when the moon is closest to the Earth.
Okay.
So the distance between... Yeah. Sun, not included in this discussion, besides just when the moon is full moon, new moon. Perigee is when the moon is closest to the sun, or to the Earth. Apogee is when the moon is furthest from the Earth in its orbit.
Okay. And so 6 months after perigee around, you'll have apogee. And because the moon rotates the Earth about once a month,
orbits
the Earth, then about like when it's in perigee, sometime during that month, you'll have a full moon. And then in apogee, sometime during that month, you'll have a full moon. So that's why it's kind of like inevitable it will happen during the year, because there will be a perigee.
Yeah.
And at like there will be a point in the moon's orbit like every month that it's closest to the Earth.
Yes. So because the moon goes around the Earth every month, it goes into perigee, its closest point to the Earth, once a month.
And because of how the Earth is rotating around the sun,
orbiting
around the sun, at some point in the year, that's going to result in a full moon.
Apogee.
Got it.
Right. So this point, the moon over on the opposite side now, the moon's yellow now, it's fine. It'll be a full moon at apogee. 6 months later, it'll be a full moon at perigee again. And the full moon at perigee is when people say it's a supermoon.
And when it's at apogee, it's an itty bitty baby moon.
I think people call it a micromoon. I don't know. It's also not that much smaller. It's really not a huge difference. It's a very slight difference. I might have exaggerated the difference here, but it's not a big difference in its size.
Got it. Thank you.
Okay. So now we're going to move into the last month here of spring, May. The sky didn't change too much, but that's fine because what you see here are pretty much all of our springtime constellations: Wotes, Virgo, Leo, Cancer. We have Libra there. So these are all our springtime constellations. And these will be the constellations that you see as we move further into spring. But there are some events in May that I'm going to talk about in just a second. But I want to tell you guys another story that that our ancestors used to remember the oncoming of summer as well. Because now we are looking at the sky as it would look 2 months from now on May 20th at 10 o'clock. If we look for Orion again, he is sinking very low in the sky. Actually, he's just gone now because he's like right here. Here's Gemini. Orion's just below there. So May, Orion's pretty much gone from the sky. You could probably catch him. Nope, can't catch him anymore. In May, Orion's gone until August, where he'll be there in the morning again, and then he'll be in the early evening during, I don't know, November, maybe. But coming out of the east in May, just after sunset, we have 3 stars with a bright red star down here. This star is named Antares, and Antares is the brightest star in the constellation of Scorpius, the Scorpion. Libra, the scales between Virgo and Scorpius. And the story goes that Orion was a very great hunter. He was prolific. He eradicated many a woodland creature in his time. So many that the Greek, I think it's the Greek god. No, I think it might be the Roman god. Either the Greek or Roman god, these cultures are very similar. Gaia, the earth goddess, did not like that Orion was killing so many or hunting so many woodland creatures. So her punishment to him for slaying so many woodland creatures was to stick him up in the sky and be eternally chased by Scorpius the Scorpion. So as the year goes on, Scorpius rises and crawls across our sky, chasing after Orion, who then during the winter time comes up in the evening, running away from Scorpius, who then chases after him again. So it's this eternal chase. And so, are you sure it's Gaia? It might be Gaia. No, you're probably right, because they're Latin formed into the Romantic languages, and I sounds like the E kind of thing. So no, you're right. You're right. So it's the Roman god Gaia, goddess of the earth, and she put him up in the sky to be chased by Scorpius for hunting too many woodland creatures. And so it's a forever chase in the sky, and as Orion sets, Scorpius chases him, and he's a summertime constellation, so when he's rising up, he chases Orion into the west, where Orion then runs up from the horizon out of the east during the winter time. But that's about all I'm going to say on that, because he is a summertime constellation, and we'll be talking about him in June. But in May, we have a couple other astronomical events that are worth noting. So on May 4th, on the night of May 4th, we have a meteor shower. I think those are always fun. Uh, Meteor showers often don't really happen, or the peaks of them really just occur very late at night or very early in the morning. And this meteor shower is called the Eta Aquarids. And so on, let's move to May 4th. And so the night of May 4th, the morning of May 5th, at around 4 o'clock, we have a bit lower than there he is. We have Aquarius over here, and the Eta Aquarids are named after the constellation that they appear to radiate from. So I'm sure probably one of the more famous meteor showers that a lot of people are aware of are the Perseids. It's a meteor shower that rains down a lot of meteors. So you're able to catch definitely any just from casual looking out of the night of the Perseids. And they appear to radiate out of Perseus. I actually have some graphics. So these are the Perseids. And the Eta Aquarids are the ones that are coming up in May. So, again, they get the name because they appear to radiate from the constellation. Now, meteor showers occur when chunks of rock fall into the Earth's gravitational pull, and they go through our atmosphere, and as they do, they burn up. Usually pebble-sized chunks of rock and ice. Now, the reason they burn up is because out in space, there isn't air. Out in space, it's for the most part pretty empty. So things move around pretty freely, and they don't interact with a whole lot besides just the gravitational pull of the sun, the planets. But when they hit our atmosphere is filled with gases. So as the rock is plummeting through the atmosphere, it's rubbing up against all of those gases, and you can this causes it to heat up and burn up, and you can kind of experience this for yourself in a way if you put your hands together and you rub them together super fast. I gotta keep talking or else you can't hear the rubbing. Your hands start to feel warm. That same thing is happening with these rocks. It's hitting all the gas molecules, the nitrogen, the oxygen, the water, the carbon. And all of this slamming into it, the rock slamming into these gas molecules, pumps a lot of energy into it, and it causes it to heat up, and eventually it just it pops or burns away. And we see that as streaks of light across the sky. Now, how did these chunks of rock and ice get there? Well, our universe, our galaxy, our solar system is filled with debris left over from when our planets formed. But the reason that we have meteor showers is actually because of something called comets. Comets are special things. So we have, in between Mars and Jupiter, we have what's called the asteroid belt. And it's just this stream of hundreds of thousands of ancient space rocks left over from when the formation of our solar system, for the most part, I would say, finished, getting us to the solar system that we have today. And they're mostly made up of rock, nickel, iron. Comets, however, are much further out in our solar system, way past Neptune and Pluto. They're from a kind of a shell around our solar system called the Oort cloud. And there consists hundreds of thousands to millions of comets. And these are cold, icy bodies comprised mostly of rock and ice, kind of like a dirty snowball. And they don't really come close to Earth all that often, but some do have orbits around the sun that bring them in closer. This comet is what causes the Eta Aquarids meteor shower, and its name is Halley's Comet. The famous rare Halley's Comet that only comes around once in a lifetime causes our meteor shower. Now, how does it do that? Well, meteors, like I said, are made up of chunks of ice and rock, and you know for yourself, if you leave a brick of ice or in your drink too long or on your counter too long, that ice will melt into water. Ice doesn't like to get warm. Well, as the comet, in this case Halley's Comet, gets closer to the sun, it gets warmed up, and out in space, ice doesn't really melt. It does what's called sublimate. And sublimation is an intimidating word, mainly because we don't hear it that often, but it's just another phase change. So, like I said, ice melting into water, melting is a phase change from solid to liquid. If you leave that water on the counter long enough, that water might evaporate into steam. Evaporation is a phase change of going from liquid to gas. Sublimation is just another phase change of something going from solid directly into gas, completely skipping any sort of liquid phase. And when these comets sublimate, it breaks apart the comet and it releases other chunks of ice that might not have sublimated yet, and the rock and other materials that might be in the comet. It leaves a trail of it behind, and that's kind of the tail of the comet. Actually, comets have two tails. One is a stream of ions, which are charged particles. You don't have to remember that word right now, but it's a stream of ions that are going directly away from the sun as the sun strips atoms off of the material of the comet. And the second tail is the trail of debris left behind by the ice releasing rock and other materials. And that trail of debris just kind of floats there out in space. And if that comet passed through the orbit of the Earth, eventually the Earth plows through that debris trail that the comet left behind, and it burns up in our atmosphere. Now, depending on the comet, depending how big it is, depending how close it gets to the sun, depends how much debris it lets out, and that density of the debris trail, how much debris is there, has a hand in how many meteors you would see per hour. So the Perseids is famous because it is such a prolific meteor shower. There's a lot of meteors. The Perseids, at its peak, meaning when you see the most meteors per hour, you see about 100 meteors per hour, so a little more than 1 meteor per minute, whereas the Eta Aquarids has only 40 meteors per hour. So you would see one every 2 minutes maybe. So less than a meteor per minute. But that's still a lot of meteors to see, and I'll probably if Becca reminds me, or if I just by some miracle remember, I'll put out a reminder about the Eta Aquarids when they're going to start up, and that way you can, plan to go out and see them around May 4th.
I definitely will, because I love seeing shooting stars, and as awesome as the Perseids are, it always bums me out when I wait all year for them and then it's
cloudy.
So
another thing to note as well is that meteor showers have a range. The day that I talk about is just the peak, meaning when you'll see the most of them, but it has a range. And the Eta Aquarids, you can see meteors ramping up. You'd see more and more meteors per night. You won't see many, but you can see meteors from the Eta Aquarids meteor shower leading up to it. I don't remember the date range. I'll add that to the supplementary info, which you can find after the show. Normally we do it ahead of time. I forgot that we were going to start doing them ahead of time, so I'll try to put it out in a week, before a week after this show. But it's a range, so you can go out and try to see meteors leading all the way up to and a few weeks after this meteor shower, this peak, which is May 4th, the night of May 4th.
Mary had a question. Does every comet have some sort of orbit around the solar system, or do they just kind of exist on the edges of the solar system?
So, gravity, if we consider it a force, is a very weak force, but it is a kind of an infinite force. So the gravitational pull from our sun is pretty huge, and it stretches out pretty far, and the Oort cloud is about 1 light year or 6 trillion miles away from the sun. But even out that far, these comets in the Oort cloud, they feel the pull of the sun. So they have orbits around our sun, even all the way out there, and that's why there's a shell around our solar system, because these icy bodies out all the way at the far edges of our solar system are still attracted to our sun. Now, most of them have orbits that keep them out in the Oort cloud, or out past Neptune, at least. Very few notable ones have orbits that bring them in through the inner solar system where the Earth is. But every single icy body out in the Oort cloud 6 trillion miles away is in orbit around our sun. Yeah.
So they're still orbiting because of the sun, but they're not necessarily going around it?
No, they are going around it. If they weren't moving, they would fall into the sun. It's just when our solar system formed, the ice and rock that formed those bodies had an orbit around the sun that was very, very slow, because it's so far out. The farther out an object is, the slower it goes around the sun. Because if it was going too fast, it would be flung out of the solar system. If it was going too slow, it would fall into the sun. So all of our planets are here today because they're made of objects that kept a stable orbit around our sun. So the Earth goes around the sun in about 365 Earth days. Jupiter, I think, goes around the sun every 12 Earth years. Saturn goes around the sun, I think, every 28 Earth years. So if I was born on Saturn, I would not even be a year old yet. But so yeah, the further out something is, if it's in orbit around the sun, it's going a speed to stay in orbit, and it has been in that orbit likely for billions of years. So yeah. So to recap again, the morning of May 5th, the evening of May 4th is the Eta Aquarids. We'll post a thing to remind you guys of that. And you'll see about a little less than a meteor a minute, so a meteor every 2 minutes. They're always fun to see. They're not going to make very big fireballs. The debris is pretty small, and the size of the meteors and the rate that they occur is usually correlated to how long ago the comet passed through our orbit. And Halley's Comet does not come around very much. So, yeah. Anyway, let's talk about... I have one more thing to talk to you guys about, and it's not really... It's something that's easy to miss, and because it's easy to miss is why I want to talk about it. Mercury is going to be up in the early evening later in May. When is that? It is May 17th. So let's move to May 17th. If you follow us on Facebook, you'll know that I just recently posted an article about Mercury being in its greatest western elongation, meaning that you see it just before the sun rises. Here, we will find Mercury on the 17th of May being in greatest eastern elongation. So what does that really mean? So, as Mercury orbits around the sun, it is closer to the sun than we are. So sometimes Mercury will be in between the sun and us where we can't see it. Sometimes Mercury will be behind the sun compared to us and we can't see it. There are times where Mercury is far enough away from the sun relative to our orbit that we can get a good look at it in our sky. Now, Mercury being so far away and being the smallest planet in our solar system, it's not very easy to spot. But if you know what to look for, then you'll probably be able to catch a glimpse of it. Now, you'll be able to see it for quite a few nights, but on the 17th is when it's in greatest elongation. And greatest elongation is when Mercury, the Earth, and the Sun make a right angle with each other, with Mercury being at the right vertice, the right angle vertice, you know, this corner right here. Now, it might not look like a right triangle. I promise you, this should be a right triangle, but because of certain orbital dynamics that we'll talk about in another show that we'll be producing soon, it's not going to look like a perfect right triangle from where I was looking at it in space. I wasn't out in space. I was using something called open space. But on this night is when Mercury will be about at its highest point that it will reach above the horizon around that time. The days leading up to it, if we go back to that little animation I had, you see it starting pretty low in the horizon at the beginning of May, and as the month goes on to the 17th, where it's the highest, and then as we continue on through May, it gets lower and lower again as Mercury gets in between us and the sun. So at the 17th, it's at that right angle. Towards the end of May, it's almost between us and the sun, making it so we can't see it. And at the beginning of May, it's just coming out from behind the sun, making it so we can see it. But it's on the 17th that it's the easiest to see it. So pretty much all through May, look out to the western or the west-northwest horizon, and you might see that little dot, that little shy planet, just peeking up to say, "Hello, I'm here. Notice me, but not too much." He's modest that way. And we have Venus coming up earlier and earlier that at that point too. Not that Venus isn't special. Venus is really awesome to see in the sky. But I'll probably do a thing on that more in the summertime when it starts getting really high in the sky, and Venus is a lot easier to spot. But I just wanted to make you aware of little Mercury over here in the west-northwest horizon on May, just in the month of May entirely. That's pretty much all for most of what's going on in the springtime, the more notable things in the springtime. I think I forgot to say earlier in the show that people could ask questions at any time. And so for that I apologize, but these shows are very interactive. Mary was able to take advantage of that, asking questions, which is fantastic. I always want to encourage people to ask questions, because that's the message that we want to deliver in Roadmap of the Stars, in Fly Science in general. We want people to be comfortable with asking questions, because I know growing up through school and college, to me it felt embarrassing to ask questions, and that's not how it should be. Nobody should be embarrassed for being curious, because that's one of the great joys of life, is being able to question things and be curious about why something is the way it is, and not taking things for granted, and just being curious, keeping that childhood wonder that we grow up with. Children are natural scientists, because they want to drop eggs and see what happens, and they want to push over chairs and see it fall and make the thud on the ground, and they want to stomp around and bang pans because they're interested. They want to know what things do, and we lose that at some point in our lives from just kind of how we think we should be behaving and think that we should know everything. But the point of life is not knowing everything. The point of life is learning as much as you can and being curious and having fun with whatever you have fun with, for as long as you've got. With that said, I am going to... I also forgot to say at the beginning of the show, at the end of the show, I always stick around a little bit, and you guys can ask questions. I have the program called Open Space up, so I can answer your questions a little more in depth in universe and in our solar system. And I'll have Stellarium up. We can talk about constellations that you might want to know about in this season, or why we don't see certain constellations. And it doesn't even have to be about astronomy. Keep it related to science, preferably. But yeah, I'm gonna be here. But with that, if you're good, you don't have any other questions. I hope that you
Thanks for coming.
Yeah, I hope you have a good rest of your evening. And I just always like to close out by saying, come back. Ask questions. Be curious. Never stop asking questions about space and science and the world around you, because there's so much out there we can still learn, so much to still learn, so much we can all still learn together. So with that said, I hope you guys have a wonderful rest of your evening. This show is automatically uploaded to Facebook whenever we're done here. Whenever I bring down the live stream, it'll be up there, so you can, take some time, spend time with family, talk about what makes you curious, and then around 9 o'clock, with parental supervision, go out and look at the stars. Try to find some of the things that I showed you guys. But with that said, we're here to answer questions. If anyone has any burning questions, if you are still embarrassed, it's not an easy thing to kick. If you're still embarrassed to ask questions, please go to our website and go to the contact page. We have a place where you can send in anonymous feedback. Doesn't require email, doesn't require your name. All it requires is you to put the subject and the message. One easy click to send it in, and then it's all up to us. We also have a section where you can add a name and an email address if you want to ask us questions. I prefer you use that. You don't have to enter your name in there. That is optional. You should enter your email address so I can email you back with the answer. And that can be completely anonymous too. And I don't share those with anyone unless the person who asked the question explicitly wants me to. So you can ask your questions there anonymously. I just want to have a lot of avenues for you guys to be able to ask questions whenever you feel like it. And I always check those emails all year round in between shows. So I'm here to answer questions, or you can answer questions on the website. The meaning of life. I had
breaking news.
I had this decision when I was in high school, and it's something that I adamantly tell people. The meaning of life, the meaning of your life, is whatever you decide it is when you wake up that morning. Like, you don't have to have an overarching, if I don't do this, I fail at life. That's a lot of pressure. You wake up, if the meaning of life is making banana bread and then watching, like, Avatar all day, that's your meaning of life. And you can do it, you know? The meaning of life is subjective. You make your meaning whatever your That's the meaning of life. Whatever you need it to be.